Hello, Algebra 1. Welcome to the start of Topic 8 covering quadratic functions. This is Lesson 8.1 on the key features of a quadratic function. So far you've talked about linear functions, we've talked about exponential functions, and now we're going to talk about quadratic functions. If you recall last topic, Topic 7, towards the end there, you were focused on quadratic trinomials, right? X squared plus bx plus c, ax squared plus bx plus c. That was to warm you up to quadratic functions, all right? I understand that when we talk about quadratic, that is a second degree polynomial, x squared. Okay, so be aware of that. All right, so let's talk about some key features so that when you hear the word quadratic or you see a quadratic equation, you have the idea of what the graph might look like in your head, right? That's our goal. Okay, so it says, what is a quadratic parent function and what are the characteristics? So this is the quadratic parent function, right? F of x equals x squared. Nothing else, no bx, no c, there we go, right? It's going to be the shape of what we call a parabola. A parabola is like a U shape. Okay, it's not a V shape because it has a rounded curve, so we're going to call it a U shape. Okay? All right, so let's go ahead and use an xy table to try to build this function. So we're going to use our 5 x values, -2, -1, 0, 1, and 2, just like we did with the exponentials. So here's my x. Now our function is x squared, so that's going to be here. So x squared. And then again, understand that's your y value, right? So again, this is your x comma y. I'm going to put x comma f of x, right? But that just means y, which is the x squared, second column. So we have -2, -1, 0, 1, and 2. All right, so when we take -2 and square it, notice I put the -2 in parentheses. When you square a negative number, it's going to become positive. So that's +4. So our first point is -2, 4. And I'm going to graph that, -2, 4. Our second point, when we plug in -1 squared, -1 squared is going to turn positive. That's just +1. So our second point is -1, 1, -1, 1. We'll plug in 0. When you square 0, that's just 0. So 0, 0 is our nice point, right? That's going to be our y-intercept for this graph. Okay. Then we'll plug in 1. Well, when you square 1, you get 1. So that's 1, 1. So +1, +1. Notice here, we're going to call it symmetry. Notice the symmetry between these 2 points. Left one up 1, right one up 1. And then when we plug in +2 and square it, +2 squared is 4. So the point 24 is on there. 2, 4. And again, notice the symmetry. All right. And again, here is going to be your picture. I'll do the right side first. Hopefully it's not too bad. So it's like this curve, and then over here it's this curve that kind of matches that one, right? Try not to go straight up and down with your arrows. Make sure they kind of go out to the side the entire time, right? Okay? But that is what our quadratic is going to look like. This is a parabola. All right. A couple things. Let's first talk about the major idea of this idea of symmetry, right? If you look at the left-hand side, compared to the right-hand side, right? They're symmetrical. And they're symmetrical about the y-axis. This is going to be called the axis of symmetry. So let me use a dotted, not a solid line. So you will talk about symmetry when you take geometry next year. But this right here, this line going down the middle, the y-axis, this is called your axis of symmetry. The equation for the y-axis is x equals 0 because all values or all points have an x value of 0. So this point this line x equals 0 is called the axis of symmetry. Okay, and again, the idea behind this axis of symmetry is that your left side is going to equal your right side. Okay, and that's a big idea when it comes to graphing, right? Because technically, you only have to find one side and then just mirror it. Okay. Now, the point where the left side and right side connect for this one, 0, 0, is called the vertex. So in your generic parent function, 0, 0 is the vertex. So again, the vertex is an important idea. Now, the vertex can also have 2 other names. When your parabola is opening up, like this one, that vertex is also called the minimum. because it's the lowest point of the U, right? If your parabola were pointing down, and sometimes it will, now this vertex is at the top of the mountain. That means that vertex would be a maximum. Okay, so keep that in mind too. I think the Ohio State test loves the idea of minimum maximum when it comes to quadratics. Two other ideas to talk about. The first one is domain and range. So if we talk about the domain, again, notice you have arrow here and arrow here, and it's a continuous graph. That means that this red is solid. There's no breaks. So that means your domain is all real numbers, just like all real numbers, just like it was for exponentials. Now I did write down there's something called interval notation, and I don't think you're going to have to see this, but interval notation is where you use like it looks like a point, but it's just like parentheses or brackets to signify all real numbers. It's a parenthesis, negative infinity, comma, positive infinity, close that parenthesis. Again, I don't know if we're going to harp on that too much, but that's the symbolic representation of all real numbers. Now your range, the y values, notice that for this graph, this 0, 0 is the lowest point. Its y value is 0. You can be that value. So 0 can be included, but then your parabola opens up. So it's anything bigger than 0, right? So our range is y is greater than or equal to 0. Right? Can equal 0, but can be anything bigger. Now to signify that, you always put your leftmost point first. So 0 is our leftmost y value, or our bottommost y value. And then because we're going up infinitely, we're going to have a positive infinity. Infinity always gets a parenthesis, but because you can include the 0, you're going to put what's called a bracket with the 0. Okay? So again, this is just called interval notation. So it's another way I'm going to put the word or to signify, but hopefully the book expects all real numbers and the inequality y is greater than or equal to 0. Last but not least, this idea of increasing or decreasing. So if you go left to right, so if you go this way on your curve, notice that the left side goes down first. That is called a decreasing interval. So we are decreasing anytime x is less than 0. 0 is your vertex. That's the turning point. So anytime x is less than 0, when it's to the left, you're decreasing, right? Again, that would be from negative infinity to 0. Then after you hit the vertex, then you start going up. Now you're increasing. And you're increasing anywhere x is greater than 0. Because when x is positive, your y's are going up, up, up. And that would be from 0 to infinity. Okay? So again, the increasing, decreasing is just some extra stuff. The interval notation is just some extra stuff. What I need you to know is you need to know the shape. It's a U shape. Know that it has an axis of symmetry going through the middle, and that vertex is sometimes called a minimum or a maximum. Okay, so let's talk about some transformations off of this, right? Okay, so it says, how does the value of a leading coefficient a affect the graph of f of x equals ax squared? So now we're going to do this leading coefficient a, which is going to put an a in front of this function. I'm going to pause it and open up Savas because we can use Savas to kind of look at some things. Okay, so I'm logged in. So let's go ahead and take a look at this this applet on Savas and see what it can allow us to do. All right, so notice here, right, our a value is 1. Okay, so this is our generic. Give me a second. This is our generic, quadratic. Now watch what happens when I move this slider and change a. Notice if I make it bigger than 1. Notice what's happening to the orange. Oh, I wish I could. Bummer. I'm sorry, what's happening to the blue? Notice the blue is getting skinnier. We call this narrower. So notice that as your a value increases, as it gets bigger than 1, your y values start getting higher faster, which stretches that or pulls that parabola tighter. So we're going to say that that's going to make your parabola narrower. Okay? Narrower. Vice versa, if I go back to 1, see if I can do that. Okay? And now let's go less than 1. Now notice your blue graph is expanding, getting wider, okay? And that's because you're taking a fraction of the actual y value, so you're not getting as high as fast. So this is going to be our general idea here. All right. So if you come back to our notes. All right. So on this graph, let's go ahead and do f of x equals 3x squared. So if the function, if the a value was 3, right, then let me give you the points. And I'm just going to, because I know them. So 0, 0 would be stay put, but then it'd be 1, 3, and 1, 3. And then it'd actually be 2, 12, and 2, 12. Again, I just take those regular y values and multiply them by 3. And now you can see that that would make this parabola, and it's harder once the points are farther away, make this parabola skinnier. That's why we have computers that draw the picture, right? So that would be a function, let's call it g of x equals 3x squared, right? So when your a value, and I'm going to put absolute value around it because if it was a negative number, that would just control whether it opens up or down. It wouldn't control the width. So if your absolute value of a, if the number a is greater than 1, you're going to get narrower, tighter, whatever you want to call it. Now let's do, what if it was a third, right? So to stick with the 3 theme, so it'd be 0, 0 still, but then it'd be 1, a third, and then it would be 2, and then it'd be 4 thirds. Because again, it's 2, 4, take a third of that, 4 thirds. So this would be what that parabola looked like. And notice, again, still give it some sort of curve. And there you go. So this would be, let's call it h of x equals, and I did 1/3 x squared. So notice now, again, we're going to be bigger than 0, but less than 1. So this is, and again, that absolute value stands hold. So this has 0, less than the absolute value of a, less than 1. And again, the absolute value just means ignore the negative. If this is true, then your graph is going to get wider. So this is definitely a recognition piece, right? If you can recognize this, this will help you understand what your graph's going to look like. So we have our regular 1x squared graph in mind, 1, 1, 2, 4, and then we have these shifts, right? We're going to call them vertical stretches, right? Stretch it wider. I'm sorry, stretch it wider, stretch it narrower. Now, I talked about ignoring the a. Now let's not ignore the a. Let's take a look at the next example and talk about what the a means. Okay? So now we're going to look at this and say, how does the sign affect? All right? So now we're looking at the sign of your a value. All right, so let's go ahead and go to Desmos and see what it does. All right, so notice now, look, positive 1, it's opening up, negative 1, it's opening down, right? So that's what's happening there. Let me move this slide out of the way. So again, I'm going to change the a. It's going to change both a's. Notice what happens, right? So the sign doesn't matter in terms of the width, right? Notice that as I get bigger, right, even if it's negative, you still get narrower. And when I get smaller than 1, right? But it's this idea that all the negative does is make sure y values flip down. It makes your graph flip down. It's a reflection across the x-axis. Okay? So that hopefully helps explain the absolute value idea to you a little bit. So when your a value is greater than 0, when it's positive. So when a is greater than 0, when it's positive, your parabola is going to open up. And remember that that vertex is then going to be a minimum. So that vertex is going to be a minimum. Versus if your a value is less than 0, if it's a negative number, now your parabola is going to flip down. And if your parabola opens down, then your vertex is going to be a maximum. And again, this is recognition. This is stuff that would be great for you to remember, because then you'd have a better idea looking at a function what the graph will look like, right? And the more knowledge we have, the more power we have, right? Knowledge is power. All right, great. So that's the end of the first video. Second video is coming up.